Here we're going to look at question 11 from section 2 of the ENGAA specimen paper. In this question, we're told we have an earthquake, which occurs at a point shown here on our diagram. So at this point, we have a house which oscillates with a period of 2 seconds due to the wave the earthquake creates. Then we're told that the wave travels out 1 kilometre and reaches another house, which begins to oscillate with a phase difference of pi/3. So with this information, the question asks us, what is the earthquake's speed? Now, if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go. So to go about solving this question, perhaps the best thing to do is to try and think about what this pi/3 out of phase actually means, what the phase difference actually means of a wave. So to do this, the best thing to do is probably to consider some important phase differences. So let's put some up now. The first being a phase difference of 0. So what this means is that the waves are going to be completely in phase. There's going to be absolutely no phase difference. So two identical waves starting at exactly the same point have no phase difference. Now if we go ahead and look at a phase difference of pi, then this is going to mean the absolute opposite. So it means that the waves are completely out of phase. So they're oscillating at completely opposite points. And if they interacted together, they would completely destructively interfere. Then finally, we can look at a phase difference of 2 pi. So what this means, as you might guess, is just exactly the same as a phase difference of 0. It means they're completely in phase and there's no phase difference. So phase difference just continues to cycle like this. So 0, 2 pi, 4 pi, 6 pi, all have no phase difference, all in phase. Whereas like pi, 3 pi, 5 pi, are all completely out of phase. So it's like a sinusoidally oscillating function, if you like. Now, with this in mind, let's consider what a pi/3 phase difference means. Now, basically, what it means is that it's going to be pi/3 of this fraction of 2 pi different. So if it starts at 0 and cycling the whole way through gets back to 2 pi to be identical, then pi/3 means that we're going to have a difference which is proportional to this difference. So with that in mind, let's try and calculate the difference in displacement. So as we just said before, it's just the fraction of our total 2 pi. Basically meaning that the wave is going to be 1/6 of a cycle behind, if you like. So what that means is that our house up here has started oscillating a sixth of the period later on than our original house, which is going to put it a sixth of the way behind in our wave pattern. So from this we can work out how long it takes our earthquake to travel from the initial house all the way to our house 1 kilometre away. So it's going to take a sixth of this time period, 2 seconds, which is going to be a third of a second. So it takes a third of a second for our earthquake to travel from the centre out to our house 1 kilometre away. Okay, and now with this information, we know how long it takes the earthquake to travel from the centre to the edge, and we know the distance. So using these, we can calculate the speed, which is just going to be the distance divided by the time. And of course, doing this, we get a speed of 3 kilometres per second. So this is going to be our final answer, which corresponds with answer E given in the question.